Alright, here's our next portion of the video screencast lecture, and we'll go ahead and do about 5 or 6 problems here on scientific notation, something that most of the science classes emphasize and certainly require at the least in their labs and in their science lectures, some of them. Alright, a typical example of one type of problem that you'll be required to know how to do. The directions will say convert to scientific notation. Okay. And the number that they'll give you will be something like 405,000, like so. The idea with scientific notation is that you want to have one digit in front of a decimal place and then several other digits following it. The last digit cannot be 0. That's the rule. So one of the other rules that we have here, this first digit before the decimal place will have to be from 1 through 9. Could be 1, could be 9. And then, of course, we'll multiply it by 10 raised to some power out here. Right? We're going to go through this example here and kind of talk about how we get there. Okay? We have 405,000, which can really also be thought of as 405,000.0. And what we want to do here is move this decimal 1, 2, 3, 4, 5 places to the left. So we're going from standard notation to scientific, and we're moving our decimal 1, 2, 3, 4, 5 places to the left, giving us 4.05 times 10 to the positive 5th power, like that. Because we've gone from standard here, standard notation, over to scientific by moving that decimal to the left. And it gets a little bit confusing when you have to go backward, but we'll address that after the next couple of examples. That's your answer right there, the part that I circled. The number here before the decimal is between 1 and 9 inclusive, and the last digit at the end of this number here is not 0, so we've satisfied the requirements. Let's do one where we're converting a number less than 1. For example, same directions, convert to scientific notation, and we are going to convert 0.0000039. We're going to convert this over to decimal scientific notation. So we move this decimal 1, 2, 3, 4, 5, 6, 7 places to the right. And when we're going from the standard decimal notation to scientific, if we move the decimal to the right, like so, then we'll get 3.9 times 10 to the negative. And that negative number there is the number of times that we move that decimal. Again, 1, 2, 3, 4, 5, 6, 7 times, giving us our answer, 3.9 times 10 to the negative 7. So the idea is if you type this into a calculator, you really would get this, what you started with right here, even though most calculators probably would not express it this original way. But they're equivalent expressions. One does equal the other. This is just a much more concise way to write the problem that we originally started with. Alright, we need to talk about going the other way, going from scientific notation to decimal notation. So our directions in that instance will say convert to decimal notation. And when we get something that says convert to decimal notation, a good example of that would be like 8.3 times 10 to the negative 5th power, like that. Alright, so here what we're going to do, what I always do, is start off with my 8.3, and now I have to think about it going backward. Now that I'm going from scientific here over to decimal, if I've got a negative number in the exponent, I know that I need to have a bunch of zeros after my decimal. It's going to be something less than 1. So I use that simple idea to help me remind myself which direction to go with the decimal. If it's going from scientific notation to decimal with a negative exponent, then you move your decimal to the left. 1, 2, 3, 4, 5. 5 times. So we get a 0.00083. So really our answer here should be 0.000400 and then an 83, and that's our answer. All right. Let's do one with the positive here. For example, same directions. We're going to convert this over to decimal standard notation. 4.1 times 10 to the 6th power, like so. In this case, we're going to take that decimal and move it to the right because we're going from scientific notation here down to standard. The exponent on 10 is positive, which really tells us that we need to move that decimal to the right 6 times. 3, 4, 5, 6. 0, 0. And of course, you don't have to draw out the little diagram underneath it, but for some people like me, that really helps. And so we should have 4,100,000 as our answer on that problem. Right, like I say, if you have any questions at any point about these, feel free to shoot me an email, and I'll try and either shoot you back an email or address this on the next video screencast lecture. We need to go ahead and move into section R3 now, which is going to cover really just combining like terms is what it comes down to. Looking at your homework here, it starts on problem 21 and it goes up at least through problem 30, and of course there are 49 problems altogether on the homework, R2 through R4. So this is really starting with problem number 21. These are the types of problems that you're going to see. First one I want to work for is here. What I'm doing, it says in the directions, perform the operation indicated. The operations indicated. What it really comes down to is that you want to combine like terms. That's what they're trying to get us to do here. So my first operation, I've got 5x squared y minus 2xy squared plus 3xy minus 5. Then I'm going to add to that something underneath it because I've run out of room. Negative 2x squared y minus 3xy squared. And then plus 4xy plus 7. Close parentheses. So really here what this turns out to be is just an exercise in combining like terms. In order to be a like term, you have to have the same letters, variables, and the same exponents on those variables. For instance, this first term here is 5x squared y. I can only combine that like term with another something x squared y. So right here, negative 2x squared y would be the only other like term I can combine it with. So I've got 5x squared y. Outside, in between my parentheses, I've got a plus, so I'm just adding 5x squared y plus negative 2x squared y. And 5 plus negative 2 is going to give me 3x squared y, like so. Sometimes what I'll do is even strike those out as I go along, just to sort of keep track of what I've already accounted for. Next I've got negative 2xy squared, and if I pan through all my other terms in this problem, the only other one like it is here, negative 3xy squared. So I'm going to add the numbers in front of them, basically, negative 2 plus negative 3, and that's going to give me minus 5xy squared, and I can strike those terms out. Negative 2 plus negative 3 is going to equal negative 5. It wouldn't be wrong if you put plus negative 5, but typically, and I know Course Compass will prefer this, to put the minus sign in between them. Alright, lastly we've got 3xy, and the only remaining term we can combine that with is this 4xy right here. So 3 plus 4 is going to give me positive 7xy. And lastly, negative 5 plus positive 7. Negative 5 plus 7 is positive 2, and I'm done. So that finishes off that problem right there. Okay. It can become a lot more tricky when you actually have to subtract two expressions like so. And I am going to have to stack these on top of each other, just like I did in the last example. Here I have 3x squared minus 2x minus x cubed plus 2. And from that, I'm going to subtract 5x squared minus 8x minus x cubed plus 4. Alright, similar problem, same concept, just combining like terms. The issue is right here with this minus sign. Okay, whenever I have a minus and then an open parentheses right here, I have to be careful with my signs. Really what's happening is I've got 3x squared minus 5x squared. Okay? So I can either keep track of that, the fact that I'm going to have to change all of these signs inside, or what I find is successful for a lot of students is to go ahead and make this minus sign a plus. But after you do that, you must change each sign that you see inside these parentheses that follow that original minus sign. This might help you keep track a little bit better. Whichever way helps you get the right answer is, of course, fine with me. But this is just advice. 3x squared plus negative 5x squared would give me negative 2x squared, like so. Negative 2x plus positive 8x is going to give me positive 6x. Negative x cubed plus positive x cubed right here just happens to cancel out for me, so that's kind of nice. And then, lastly, I've got 2 plus negative 4, which is going to give me a minus 2 at the end, and I'm done with that problem. We'll go through one more of those, and then I'll pick up in the next video screencast with our factoring and foiling and multiplying. Alright, last one we'll do right here. I have 2x to the fourth minus 3x squared plus 7x. From that, I'm going to subtract 5x to the third plus 2x squared minus 3x plus 5. Alright, and I'm going to use the exact same trick that I used in the last problem. I'm going to change this minus sign to a plus, and then after I do that, I need to be sure to change the sign on every term here inside my parentheses. Okay, so the positives become negatives, and the negatives become positives, like so. Okay. Alright, now that I've got that finished, my 2x to the fourth, I'm going to add that to the other x to the fourth term. Since I don't see one, the 2x to the fourth is just going to stay as it is. Negative 3x squared plus 2x squared, right? Negative 2x squared right here. And negative 3 plus negative 2 is going to give me minus 5x squared. Many of us may have noticed that I've left off this negative 5x to the third power. Unless course compass states otherwise, you can put this term anywhere in your final answer. They may ask you to put it in descending form, in which case the exponents would have to go from largest to smallest. Otherwise, we could just keep that negative 5x to the third anywhere in the answer, as long as it's there somewhere. Obviously, I can't combine that with anything else in my problem because I don't see another x to the third term. 3 more terms to worry about. 7x plus positive 3x. 7 plus 3 is going to give me 10x, like so. And then, of course, my last term out here is this negative 5. So I'll just tack that onto the end, minus 5, and that would be my answer. Now, in the event that course compass says it must be in descending form, that means that they want the largest exponent term first, working its way down to the smallest exponent term, or just plain number in our situation here. So if it wanted it in standard form or descending form, we would have 2x to the fourth minus 5x to the third minus 5x squared plus 10x minus 5. Once again, this here is what we call either standard form, or could be called descending form. Descending order sometimes is what they call it. Okay, I'll go ahead and stop right there, and then I'll pick up with the multiplying, foiling, and factoring in the next video screencast.